Hi student, today we are going to discuss about impurity defects or we can say extrinsic defect. So this defect arises when foreign atoms are present at the lattice site or at the vacant interstitial site in place of host atoms. This is we are taking the ionic crystals, ionic solids. Here we are adding the impurities externally. We add the impurities externally in ionic solids or ionic crystals. Here this is the lattice site. This is the interstitial site, vacant interstitial site. So the foreign atom means external atoms or ions or impurities. The foreign atoms are present at the lattice site or interstitial site in place of host atoms. The foreign atoms are present at the lattice site or interstitial site in place of host atom. This is the host atoms. Host atoms or ions. So is called a impurity defects. Impurity defects. Here the impurity defects we can obtain by introducing the defects in ionic solids by adding impurity ions. If the impurity ions are in different valence state from that of the host ions, vacancies are created in the crystal lattice of the host. The addition of impurities in the ionic solids, the impurity ions are in different valence state. Different valence state. There will be a vacancies are created in the crystal lattice. For example, addition of cadmium chloride to silver chloride crystal, or the addition of strontium chloride to sodium chloride crystals. Now let us see the examples for the addition of cadmium chloride to silver chloride crystals. So this is the silver chloride crystals. So when we add this cadmium chloride to the silver chloride crystals, here the Ag plus ion is a monovalent cation and a cadmium 2 plus ion is a divalent cation. So the addition of cadmium chloride to the silver chloride crystals, it gives a solid solution. Where the cadmium 2 plus ion is a divalent. It occupies the position of Ag plus ions. This will disturb the electrical neutrality of the crystal. The addition of cadmium chloride to the silver chloride crystals, the cadmium 2 plus ion is a divalent cation. It occupies the position of Ag plus ion. Due to this, the electrical neutrality will be disturbed. So in order to maintain the electrical neutrality, 2 Ag plus ion is replaced by 1 cadmium 2 plus ions, because the cadmium 2 plus ion is a divalent. For maintaining the electrical neutrality, the proportional number of Ag plus ion is leaves from the crystal lattice. So this produces a cationic vacancies. This produces a cationic vacancies in the crystal lattice. Such a type of effect is called a such a type of defect is called a impurity defects. So what is the use of the impurity defects? The presence of impurity defects in a ionic crystals, it increases the conductivity of solids. It increases the conductivity of solids. So in the conductivity of solids, the conductivity of solid increases due to the presence of impurity defect. The conductivity of solids increases. So from this we can make n-type semiconductor and a p-type semiconductor. N-type semiconductor and a p-type semiconductor. So the addition of impurities to the crystalline is called a doping. So we add the impurities externally. So the addition process is called a doping. So we can say that the process of adding impurities to the crystalline is called a doping. Okay, do you understand, student? This is the impurity defect or extrinsic defect. Thank you, student.